பார்க்கல சொல்ற டேலண்ட் இருக்கணும். கவுன்சிலி பிஎஸ் போட்டு ஃபைனல் இயர் போடு. என்னோட மைக் ஆன் தான்.
Good afternoon, dear participants. Today being the last day, we have the 11th, 12th and 13th session pending for the day. And we are starting with the first session of the day. And good afternoon, all of you. And today we have with us Mr. P.S. Rajan. So I would like to introduce him. He is our resource person for the day. And he is handling the topic called modern evaluation, valuation and deployment. So Mr. Rajan is actually, he is a senior technical specialist at HCL Technologies, Chennai. He has a 20 years of global experience in IT industry. He is also an alumni of Department of Computer Science and Engineering at Pondicherry University. And later he has pursued his master's in management at the Grenoble École de Management, France, one of the Europe's leading business schools. He is a unique blend of strong technical expertise and management skills, and which has enabled him to excel in both as a consultant and as a leader. His professional journey has taken him across India, USA, and Europe, where he has worked in diverse roles from mainframes at Cognizant to cloud migration consulting at TCS and currently to cloud and DevOps consulting at HCL Technologies. With a robust skill set spanning programming, data analysis, SQL project management, and cloud technologies, he continues to drive impact solutions for global clients. Mr. Rajan is also the author of the GCP Cookbook, a valuable guide for all the professionals who are working on Google Cloud. He is widely admired for his passion for solving the complex problems, embracing challenges, and continuously adopting to new technologies. We are honored today to have him amidst of us and looking forward for a very good insight for him on the topic model evaluation, validation, and deployment. Welcome, sir. Welcome for the session, and over to you, sir.
Thank you, Dr. Tarani.
Thank you.
Yeah. So let me share my screen. Yeah. Yeah, my screen is visible, right? My screen
Yes,
is
sir.
good. Okay, cool. Okay, let's get
Sir,
started.
it's visible. Your screen is visible.
Yeah, thank you. So we are going to talk a lot about model evaluation, but not in the classical sense of model. We're going to talk about large language models. And please note that this is going to be an engineering view on LLM evaluations and not an academic or a research oriented view. What do I mean by that? As an engineer, I am worried about, I'm building a bridge. I'm worried about the cement, the iron, the sand, right? I'm not worried about what goes into the iron, what temperature it was twisted, and what silicate and what oxide was there in cement. I'm not worried, but I'm worrying about the mechanics of it. Right? I get a recipe from the lab saying this is the portion of water and rice, sand which needs to be done, and I take care of it. That's the same logic I've applied on this, and that's where I'm bringing you on. This is not an academic view, so a note of caution and introduction on what we're going to look. So we are going to look at large language models, how to evaluate them, how are they evaluated individually as models, and how are they evaluated as systems, right? Because in the industry, we work on LLM systems and applications. We don't work on LLM. That's the OpenAI and Gemini. Those are the teams who work on LLMs. We don't work on LLMs. We use LLMs to build LLM systems. Yeah, it is important, it is challenging, and it's a state of the art, right? So it started 2 years ago, and tools have been enabled, the ecosystem has built, and now we are in a mature enough stage to build products which can be shipped into production. And there are production ready and production systems which are using LLMs right now as we speak. Okay, and so what is LLM, right? What is LLM from again, everything is going to be from an engineering point of view. So it's a large language model, large because it has lots of data, right? It consumes a lot of knowledge. There are parameters. You measure it in the way of how many parameters are fed into the model. Now it is in the order of 7 and 31 and whatnot, right? It's in billions of parameters. So it's a large model, and it's a language model. It's a language model because I'll come to language later. Let's do model. Model is nothing but it's a machine learning model, right? Machine learning, the old school, where you give data and then you ask a question on it, or you ask it to extrapolate, you ask it to segregate, you ask it to do a task you on the data given. In this model, the data given is the language. And what is language? What we use to communicate, right? We communicate to add numbers, we communicate on a business idea, we communicate on a relationship problem, and everything is language. And that's what LLMs try to do. They try to build in knowledge, mathematics, empathy, understand the context, a lot more, which the earlier models were not able to do, right? Earlier models would do uh, classification, right? Can I give the loan to this person or not? And what is the risk of default or not, right? It used to do regression and classification and a little bit of extrapolation. Here, large language models are getting closer to human-like, right? That's where LLMs are. They are trained on. Yes, we'll see a few big models which we have at the moment. This one. This is, yeah.
Sir, kindly make your PPT into slideshow or presentation modes.
I can, but I'll have to move out a lot. Yeah, I'll do it for now, but I'll be moving out a lot. So I thought I'd do that. Okay, sure.
Okay, thank you.
Yeah. Yeah. Is the word token visible if I keep this window like this? This orange color box?
Yes.
Do you see?
Yes,
You're
sir.
able to see this. Okay.
Yes, sir, it's visible. Yeah.
Yeah, it's visible. Okay, so then this is just a distraction. Okay. So large language models, you would have everyone uses a lot of ChatGPT, and then now in the Google, we have the AI thing from Gemini. Those are all the popular ones. And then just to show the size of data and the tokens involved, like GPT-4 is trained on 1.8 trillion tokens, right? We'll see what the token is. And Claude and Palm and GPT and BERT is from Google. So the size in which is going, it is a very, the more scale is applied here. It used to apply for transistors and now it is applied even for data, right? A few years ago, it is in half, not quarter, less than quarter billion, like even quarter, 1/8 of a billion, right? Here it is in, we are talking in trillions. So what's the token, right? When we say, we use it a lot. And whenever I put an orange box, it's a vocabulary which we learn, which we want to build upon in this session. A token is can be a word, it can be a part of a word, it can be it is important for it to understand the context, right? So today is a beautiful day outside is divided into these tokens. The full stop is important. The capitalization is important to understand that it is the start of the sentence. The punctuations are important because it has to understand the tone. It has to understand how to reply, because you can ask large models are very, can explain it to a 5-year-old. It can do it in a funny way. It can be straightforward, right? You can ask how it should behave, and it learns everything from tokens. Yeah, and these subwords are then turned into numbers, and the model at the core will only understand numbers, right? Because the CPU at the end understands ones and zeros. The model will understand only numbers, and they are all coded separately, and that's our token. So just to see a short demo, if I go back to this. Tokenizer. Yeah, I have a tokenizer here. So for example, I can type this is a session or computer enthusiasts. And for, and then I don't have the token numbers. Yeah, token IDs are also there. Let me put for, again, put computer, I can put again computer. So this is how it's being split. And these are converted into numbers. For example, do we have anything repeating? Another computer, 75595. Yeah. So the word computer with a space, if I put another space at the end, that's a different token. But the word space computer, that's how it's split up, right? And the text, it's a space computer. A space computer with a capital C is different from a space computer with a small c. And those two are 7595. right? So this is how we need to understand tokens, and this gets fed into these large language models. So that one first thing we try to understand is the model token, the word token. Let's see, and these are the popular models, and we call it the frontier models right now. ChatGPT from OpenAI, and then we have Llama, which is an open source from Meta, from Facebook and all. We will be playing around a little bit, mostly on these two. Then Google Gemini, we are introduced into it in Gmail and Google search. We are all using it. Claude is one good, very strong contender. We use it a lot in development. Grok is from X or Executor. Perplexity is again from Perplexity. These are mostly closed source, except for Llama is open source. Perplexity, I don't know. Claude from Anthropic is closed source. I think it's open source. So yeah, different flavors which come in. Yeah. And so when we go to an LLM and we ask for something, and this is the flow of it. The LLM is pre-trained, frozen in time, and then it is available. So we call it ChatGPT 4, 4.1, 4.1 mini, ChatGPT 5, whatever. It's frozen in time. Prompt is something which we give as a user. A context window, we can pass it. We give it some more context for it to help us understand better. Yeah. So a prompt, and we'll see what is a prompt and a context. Yeah. So I'm going to show the same thing, what you guys would have done it 1,000 times, but just for the sake of learning, let's say explain summer works by year. Yeah. So this is going to generate an answer. So this, would you like to take a fun story or a rhyme for a kid? It understood 5-year-old is a kid, and then it playfully explained it. So I'm going to ask it, explain winter. Now, will it do it as a for an adult? It obviously understood the context. It remembered the context that a 5-year-old and it is a kid, and then it explained winter again as a kid. So this is ChatGPT. I think it will be 4 or something. And I am also running Olama on my Olama is a tool to run a large language model on your local machine. And I have 2 LLMs available. I'm going to use Llama, which we'll be using later also. Okay, let me run this Llama 3.2 model. Yeah, so explain summer, right? It's so it is explaining summer. Normal discussion, it understood that it will be an adult, and then I can ask explain summer as to a 5-year-old. Yeah, it scales down the difficulty. It'll use a little bit fun language to explain it to a kid. Now, if I do explain winter, it will ideally it doesn't remember that it's only a kid, right? It went back to this. So Llama is open. It's a little bit less powerful or less context knowledge than its public contributors, but it's by design, right? It has its own use case. So what wanted to show is we tried a frontier model and an open source model running on my machine, just my laptop's power, and with whatever knowledge it had. You would see that the answers are different. The way it defined, the way it understood, the way it kept track of who I am is different. But nevertheless, you got a flavor. So that's what I gave as an input is a prompt. And context is what I can give or it can understand. In this example, you would see explain it to a 5-year-old was a context I gave. It's nothing to do with summer, right? Or explanation. But I gave it a context, explain it to me as a kid. Here, I didn't even say that, right? Explain it to me as a kid. It understood my previous conversation, and then it started talking to me like I was a kid. Yeah. So that's context and prompt, and those are important uh, features which we need to understand for an LLM. So what we are going to see today, ideally, we are going to see what LLM system evaluations, LLM application apps evaluation. That's what our focus area is. But we'll also look at how are models even evaluated. How is it looking like? Yeah. And this also bears fruit in the longer in the broader sense of LLM evaluation, right? Because you need to select an LLM to run your system on, right? There are hundreds of LLMs right now. Yeah, we need to select that before we even build our system. So yeah, from here we are going to switch between this and this, right? We are going to be LLM system and LLM pure models. I will call out explicitly, but it is by design I am switching these two for one reason, because the concepts and terminologies which you need to know to appreciate a pure LLM model, you will understand when you do this, right? So I'm going to be switching between LLM systems and LLM pure models. Bear with me, I'll try to call it out. So now in the next 3 slides, we are going to look at an LLM system, LLM apps. So LLM apps as in what can you build using LLM, right? What are the applications we are currently building using large language models? RAG is one, very popular, right? We are going to look at a lot of RAG. I think at the end of the session, you would have an appreciation of RAG. Retrieval augmented generation, because we are going to look at demo and code and all that. So it's just an introduction. We have agents, and then we have NCP. Agents are it's kind of a piece of code which can decide on its own. You write, you take a Python code, you write an if statement, right? Depending on the input, it will do execute the true part or the false part, right? So agentic is, we'll take in a lot of parameters. We'll use LLM to get a result and take decision. It will not wait for a human and take decision as in create in an instance, book a ticket, which is financial, which will have a financial event, book, buy a stock, sell a stock, right? So those kind of systems can be built using agentic AI. So whatever a human had to do before, can I buy the flight ticket right now at 6 a.m., which is at 650 rupees or dollars, right? Before a human had to take that decision, now LLM can take that decision. Yeah. If we train it enough and we give it all the boundaries, it is possible to do. And that's where an agentic AI application is. And MCP is another new protocol which is facilitating all this. And it's a standardized protocol which will help communicate between a lot of systems, right? And this is nothing to do with LLMs, but it's a nice topic and a segue which it's better to understand, because building large LLM systems, understanding MCP is becoming implicit. So MCP, Model Control Protocol, is nothing but a new way of protocol. In a traditional way, I need to, let's say this example, right? The application wants to get weather, book a hotel and book a restaurant depending on the weather. If it is sunny, I'll book a terrace, right? Outside of an hotel, I can in the lobby, not the lobby, sea facing front. If it is rainy, I want to eat inside, right? And how do I want to choose it? And I'd make an API call for all of this. But in the MCP world, you do it once in a standardized fashion, right? It simplifies that task. So for example, in this example, so you make a call to the weather API. Yeah, once you make a call and then you provide authentication to get it. And then to the restaurant service, you make a call to the Yelp thing. And then to make a reservation, you make a call to booking.com. And so you have an APIX key for authorization. Here you have a bearer token for authorization. Here you would have a token, right? An API token. So you have three ways of authenticating into this, right? You have three different authentication patterns. This MCP will facilitate that, right? You use the new protocol, you will authenticate in a similar way because the weather service will expose an MCP server for an agentic or an LLM application to talk to it. So this eases the way we discuss between bots. And that's the thought process between this MCP. It's getting really gaining traction and popularity because we want bots to talk and decide and take, and it ties a lot with the agentic AI, right? It has to talk to the weather API to get the weather and then decide which place to go and then decide on what booking it needs to make, right? So MCP servers come in a lot handy. So these are applications of LLMs. Yeah. So we are going to look at RAG at a high level. No, we're going to get into detail of RAG, and then we will go back to pure models. Yeah. So what is RAG? RAG, retrieval augmented generation. So yeah, we'll come into the why it is named like that. We'll go to an example. So at a high level, if I ask a specific question to a language model, depending on my company or on my knowledge subject, it would not have, right? The LLMs are trained on public data, right? On the internet, data sets, whatnot. But if I have something very close to my organization, let's say I am Amazon.com. I know the prices of few articles, right? And that will never get out of the organization. And I need knowledge, or I need to make systems out of it. So I can fit external knowledge into the system so that I'll be able to get an answer. So this is, should we go to the example? Yeah, so this, I'll go full screen. So we are going to use a large language model, which is the core. And this does not have my company's knowledge, right? I have stock prices. I have what stocks do well in this part of the country or that part of the country. So what we need to do is we need to feed that external knowledge so that this LLM can understand. What we have is either it is in a database or it is in text files or in PDF documents. We will have it data in different manners. So what we do, we first take these documents, we convert them into a number which could be understood by LLM, right? I have a product called laptop which is sold at 50,000 rupees. That has to go into a number. It has to be converted to a number so that LLM can understand, right? It cannot understand Lenovo. It has to understand 53 and 48 and in context. So that's where this embedding and vector database, these all come in. So embedding is nothing but we cut these data, convert them into smaller chunks and numbers. So the output of this step would be numbers. I will have Lenovo, 50,000 rupees, sells well in Chennai, doesn't go well in Delhi, all that stuff. At the end of it, you will get 53, 47 numbers. You get a bunch of numbers. You store them in a vector database. And then this vector database will be huge, right? Because Amazon has a lot of knowledge. I cannot feed everything into the language model. So I take what is necessary, I give, and that goes as context. Let's say I have information about laptops, I have information about dresses, I have information about shoes. But when my question comes in for laptop, I need only the laptop details into the LLM. I don't need to give data on shoes and dresses. So that's where the similarity search comes in. In the first step, I crunch all the data, store it in the database. When the user query comes in, what is the best-selling laptop in Chennai? Then I go to the similarity search. I get data about laptops, and that is called context. And the query is, what is the best-selling laptop in Chennai? Feed it into the LLM, and then get a response saying, yeah, the best-selling laptop in Chennai Science from Lenovo. Yeah. So RAG at a high level is giving your external knowledge to an LLM so that it can help you respond. Okay. Hope that makes sense. I will move to a demo to show this code of all these different parts. So we had embeddings, vector database, context query, and the response, right? And user query. So all this we'll see in the code. So yeah. So yeah, I import a bunch of stuff. So I have a report for a company called Cisco. I have an annual report. I'm taking the PDF, right? I'm taking their annual report, splitting them, chunking them into smaller bits, creating a world of. I'm taking just 100 length, 100 characters, and then splitting them. Then after we chunk them, then we get we convert them into something called embeddings for a specific model. Embeddings is what? When we convert this text into numbers, right? It's kind of tokens, yeah. What we saw tokens. Embeddings, it's not exactly the same as tokens, but for a higher understanding, we can just keep it is tokens which can be fed into the model. So we convert them into embeddings, and then I store it into a vector database. So Chroma is a vector database which we have chosen. We store all these into a vector database. And see this storing a small PDF, it took 6 minutes to chunk them, store it, understand, and all that, right? This is a huge process. But all here will all quick process, right? You're reading a file, you're chunking it, it's all done in memory, it's pretty fast. But when you save it to a database and actually convert it to an embedding, that takes a lot of time. That's why I'm not running it live. I ran it earlier. So here is the RAG part, the retrieval and generation part, right? Here, so I am giving it a context. Yeah, you are an AI model. Give me answer. I'm going to give you a context and all, but you give me correct answer, right? So I give it a context and I give it a question. I give it a question, right? What percentage of executives are women? So let's say I execute this, and the model I'm using is Llama 2, which is running on my local machine, right? Let me give this question to Llama. Yeah, I hope I didn't close it. Yeah. What percentage of executives are women? There is no context. I'm just asking the model this, right? It understood at a global context, right? It took the whole world as a context, and then it's saying global average, company size, and all. But here we are giving Cisco's annual report as an input document. So this has some context on it. So we are going to execute, and then the context. And there is another step called the context retrieval. In the previous example, I mentioned that Amazon, when we ask a question about laptops, right? We don't need to feed the external knowledge about shoes and dresses. We just need to give about laptops. See here, the question is executives and women. So the similarity search. So this step goes to the vector database, takes all information which are related to executives and women, and then it'll take that as a context, and that is sent to the LLM. So the prompt is sent, the retrieved context is sent, and then you get an answer. And when you run this, right? I think I can run it again also. Takes 5-6 seconds, I think. So according to the context, 46% of executives are women. So now it is using the same model. It is using the same model which is running on my machine, but this time it had more context. And then it gave me a better answer of what women I'm talking about, what company I'm talking about. It all depends on the input PDF file I provided the model with. And let's go back to the presentation. So we saw about embedding, converting text and PDF documents in embedding, storing it in a database. then we get the relevant context. We are not going to send the whole database because all the embeddings can be a lot. And LLMs have an input context limit. It can take only X number of tokens as input. So there is also a limitation. So we filter out what is necessary. We give our query to the model and then it will wait for its response. Yeah. Okay. So now we are going back to the old models, like the real core models which we use. Now we are not into the model apps world. We are going back to the real models. So in the old school frontier models and open source and closed source models, we have to evaluate them on different benchmarks, right? How is it responding? So when we saw this response, we say, oh, I like it, I don't like it. Maybe it's not clear. So there is a human evaluation. There are technical evaluations on public models. We will see a few of them. There are a few leaderboards in Hugging Face, which will give us a glimpse of how they are done. Let's look at the coding leaderboard. Hugging Face, big code. Yeah, this is a coding leaderboard. So what models right now are good at writing Python code, Java code, JavaScript code, C++ code? How are they doing it? The Quen is leading it. DeepSeek from Quen is from Alibaba, I think. Pi is also coming really popular. Llama is here. Llama 70 billion is doing better. Code Llama is another model where there are chat GPTs and all. They are GPT models. I think they are falling behind because coding specific models are really taking the cake. Like 3 months ago, you would see GPTs, right? GPTs here. Now they are all gone. And you will also see a performance plot of how good they are performing, how much memory print they need, and all that. And another kind, these are OpenLLM leaderboard. I wanted to talk about one more leaderboard, which is on performance. Is this the performance one? No. Yeah, this is on performance on different architectures. So Microsoft Phi is really leading. When Llama from Meta, it's also doing really good on these kinds of machines. So find your best model. This shows what is the OpenLLM score, how is it doing better, and what is the memory footprint on it. Let's say this one has a memory of 9 gigs, right? 9 gigs of memory. Bigger the dot, it takes a lot of memory to process, which means CPU, GPU altogether. So these are the different popular models right now. And we will use this when we build our LLM systems. We take this into consideration, how much machine capacity I have, how long can I wait for the result, and what is the best model. And closed source, I need to pay money. If it is open source, can I run it on my machine? Is my machine good enough to run that, right? So you see local, this Llama is pretty responsive, but this is a smaller model, right? Llama LS. Right, it's a 5 billion. No, I can't run this. Right, this is I think it's not even billion. Right, it's a 1 billion smaller version. If I run the 5 billion or the 70 billion, my system will hang. It will take forever for the result to come back. So those are all considerations which we will use when we look at open frontier LLM models performance. Yeah, there's one more. So Vellum has a very nice leaderboard, which evaluates on context, how they do in coding, how empathetic they are they giving, are they biased? They do a lot of stuff. So Grok from Twitter X right? GPT from OpenAI, Gemini from Google, OpenAI O3 model. So these are different models, and then on high school mathematics and all, right? I'm not going into details. Coding will be really nice. Where is it? Yeah, so comparing models will also come in handy. So context size, what we saw. So context is what we feed in. For example, in the RAG model, I need to give the context to the model, and the number of tokens it can take. For a GPT-4 can take 128,000. Claude can take 280,000. But if you see Gemini and all, they can take in the millions. Gemini, yeah, for example, 3.7, this is taking 128. Gemini 2.5, yeah. See, Gemini 2.5 Pro can take 1 million tokens. Geminis are usually very good at context taking. You can feed in a lot of context, and that's relatively cheaper priced. And then, yeah, price is one criteria, and then you have all lots of other criteria to take care. And until when it was trained, right? Gemini 2.5 is trained till November 24. ChatGPT has 5, which is pretty recent, April 2025, still more recent. Yeah. So model comparison on different, these are intrinsic parameters, human or mathematical ability, language abilities, Spanish language, multi-language abilities. So model comparison on context window sizing. GPT-5 can now take 400,000 context. Gemini is still at leading 1 million. GPT 4.1 nano can take 1 million and all that. So these are all come in handy when you build your systems. Yeah. Anything coding, there will usually there is a nice board which helps you in coding. Yeah, never mind. Coding leaderboard. How well it helps you debug your code, modify your code, and all that, sir. We use this a lot in Google, GitHub Copilot and our other internal tools, WinSurf and all. So if we have to really show in our code, so these models, for example, we can select these models. Also, we have option to these models. This is a tool, and then there are lots of other tools which can help you code, and they will help you write code. For example, if let's say I want to write code on write a shell script to delete files from /tmp and give me the size saved. And then it'll spit out the code. I mean, ask mode, is it? Okay. In agentic mode, it'll spit out the code. Yeah, take a short break from my rambling. So it will write the code. We can use it. We can ask it to test it. Can modify the code. We can say, don't do this, do that. So I can, where is it? So I can apply it on my, I can play it, I can copy and paste here. This is the code which I can execute. Yeah, needed. So so this tool uses a lot of models to generate them. That's what I wanted to show. Okay, so let's go back to the presentation. Yeah, LLM Arena is a nice one, which plays a lot on human assessment. Really wanted to see that. LM Arena at 2 and 5 qubit before squaring. I'll go to the leaderboard while this processes. So, so this is a lot about human evaluation. So, LM Arena will run the same prompt against 2 different frontier models. Will give us a result, and then it will take that as an input. So they have their own leaderboard in for text, for web development, for image editing, for searching, for vision, text to image, and all that. And then these are human scores, right? People have evaluated them, like we will do right now. So So assistant A came up with an answer of 1176, 49. Both are same, right? And then they have explained it. So I think I like them both. So let's say it's a tie, or I can say left is better, right is better. So I say let's say it's a tie. They will reveal us what model it is. Yeah, and yeah. Yeah, this is the Quen 330 billion model, and this is a Monterey model. I've never heard of it. So this gets captured in the leaderboard. Yeah. So. So we have quite some time. I will go into the evaluation. So there is intrinsic evaluation. I'm really not going into the details. So an intrinsic evaluation is how the model is built. What was the how it is trained? What is the company behind it? What is their thought process into it? Are they investing on speed? Are they investing on fairness? Are they investing on covering a lot of ground? So those are, and how their models are trained. Is it open source? Is it closed source? What technology they are using behind it, right? The transformers and all whatnot. So there is an intrinsic value, and then you can evaluate against it. And then extrinsic is what we really saw, right? We saw human evaluation on how it is doing, what is the output, and all that. So there is an extrinsic evaluation of large language models, and there is an intrinsic one. And human in the loop is really important, because even ChatGPT, when they really left out their version 2, the human feedback was really key for it to be in a presentable state, right? Without human feedback, the LLMs couldn't survive. Now we have a lot of human input stored in datasets, which we can really feed, but 5 years ago we did not. And scalability, right? And when we build these models, and I need to evaluate them, I cannot always go to human in the loop, right? I cannot have a person dedicated to verify that is doing good. And I cannot do it in the middle of the night. Let's say I'm on an LLM system, I make a modification, I need to verify and put it to production. I cannot wait for someone at 11 p.m. to open it, verify, validate. So how do we use LLM to validate itself, or a couple of testing to validate if it is good or not? So, and so these are challenges which currently the industry is solving. And we'll see one example about that. Yeah, we're going to see about RAGAS. So RAGAS is RAG assessments, right? So how do we evaluate RAG systems? So that is one we will see, and then we'll really close. So that's the last demo. Get rid of this. RAG evaluation. So in RAG evaluation, so we will do RAG, right? We will do retrieval augmented generation, which means we give context, we ask it a question, it will give an output. I'll explain the code. So it will be a refresher for RAG. So what we used to do for same, the first part is RAG, right? I'm giving input, I'm asking it a question. So I'm taking a bunch of documents and then feeding it in. Here I have a couple of text documents here. I'm feeding it to this. I'm taking these documents, text files, then I cut them, convert them into tokens, convert them into embeddings, and I do all that. Right at the end, it'll all be numbers. Vector store documents are this, but embeddings, yeah, at the end they are all stored in a vector database in the folder called ChromaDB. So I have all these documents, Galapagos Islands, New York, and all these text files stored as numbers in this vector database. Then I give a prompt. Okay, I'm using the Llama model, which is running on my machine, and all these models have different input criteria. I'm not master of it, but you eventually say, how should it treat my question? Can it give a global answer? or I need a precision answer, what and lot of other parameters I can feed to the LLM on how it should behave. And context and question are what we discussed earlier. So the context will depend on the question. If I ask a question about shoes, the context should have everything about knowledge I have on my organization about shoes. If I have something about laptop, the context is about laptop from the set. So for example, in this question, who discovered Galapagos Island? So lots of stuff about discovery, Galapagos Island, how all that ideally there in this. And I don't want to give all this, right? Whatever is there about discovery and then about the island will go into the text. And I want you to note, I'll call again. So here, I did not take the real name. Okay. I made a goof up. I purposefully changed the real person who discovered the island to Surya Ramaswamy, just to show how systems work. Yeah. So in my knowledge, in my internal knowledge, I have given Surya Ramaswamy is the person who discovered Galapagos. Keep that in the corner of mind. And that is what I have given as a ground truth. And ground truth is my expected answer for the question given. Yeah, I'm expecting that in 19th the Bishop of Panama, Surya Ramaswamy, discovered Galapagos Island. This is my ground truth. And this is what I expect as an answer to this. Because that's the data I'm feeding to the LLM. Yeah. And so there is queries, there is ground truth, which is my expected answer. And the results and context are output of the LLM, right? The QA chain or the RAG chain. So I give the LLM the query. It will receive the context from the previous step, and it will generate the result. And they are all concatenated into this array. So the results, and they all come out. So you see one here, it came back with an answer of Thomas de Berlanga, who's a real person who discovered this. But in my input, I don't have this name. I have Surya Ramaswamy. But still, it gave this answer. But this is the actual correct answer to the whole world. This is the flaw, or this is how LLM works. LLM has its own knowledge, right? So I shut it down. I might have asked. So LLM has its own knowledge from what it has learned, and it's not easy to crush its knowledge. We can, but it takes a lot of effort. With just 4 files and one RAG pipeline, I cannot nullify its knowledge. I have to really forget this was changed and all that. Only then it will really understand. So for now, it gave me a wrong answer from its existing knowledge, not from the context I provided. Yeah. So we have results, we have context, which is part of the RAG chain pipeline. And yeah, so then we feed this into the RAG as step. So RAG as is an evaluation model where it will take LLMs, embeddings, the context, the result, and all that, and it will make a measurement. Let's go fast. So here is where I'm calling the evaluate function. I'm giving the data set. I'm giving a couple of features against which it should measure faithfulness of the answer, correctness of the answer, fairness of the answer, and all that. See, this step took 12 minutes. So it crunched all the data, and then it will come out with the report. So it will process, and then it will come out with a report. And lots of things are failing, not a number. And this is because I'm running on an LLM. Excuse me. See, if I would have run it on an OpenAI or another better AI solution, it would come out with all this. For my model, I couldn't get this to work. Yeah, so it would work, but I need to dig a lot. So for now, I have similarity, and I think one more value is coming out. So for each question, it will check. It'll compare the result with the ground truth. Is it the answer is as expected? And it will also evaluate the context. How well are you picking up the context for the question given, right? I'm asking Galapagos, don't pick something about Saudi Arabia, right? So that is also measured. So RAG assessment does that, and then it comes with an evaluation. So these all would be numbers, right? Yeah, it'll be fairness and correctness and all that. And then you will see for each and every, can I scroll right? For each and every question, you will see whether it is correct or not. Yeah. First one, similarity, but for correctness, this will fail, right? Faithfulness and answer precision, this will fail. Yeah, you'll get a 0. Because my answer is Surya Ramaswamy, but it came out with a different answer. So that's how we evaluate RAG models using the RAG assessment. Yeah, and then this is an automated assessment, right? So it does it on a large scale, and it will help us fine tune it better and whatnot. So that's why this is a framework on itself. So the path forward is when we build anything, any system, production system, we always develop, test, modify it, deploy, test it, modify. It's always in a continuous loop, right? And that applies the same for applications which are built using LLMs. There's always continuous improvement. And then validation, we use a model, or we use human evaluation. We take different steps to get to there. Okay. So LLM ops is kind of relatively new. ML ops is pretty well established these days. So here we are talking about models, statistical model, all different complex models, where we has a specific goal, a specific data set, a specific test data set, a specific validation data set, and then you test against all this and make sure that validation, your check marks are met, and then you can deploy the model into production. For example, for loan, can I buy this stock, or specific models which are really on data. LLM models, we don't train them and all. There is a topic called training LLM models called fine tuning, which we did not touch upon. What if we want to feed that knowledge into the LLM itself, right? Let's say here. So let's say it's vector database so big. Let's say Amazon takes all its sales and data and then creates a vector database which has like 1 million parameters, or close to 1 billion parameters. It's like 1/7 of the size of the model. Then you can say, okay, I can use this data to retrain it, right? Or feed this knowledge into it. We don't have to go even that much, right? Even if at the million scale of tokens, you can retrain LLM models and then create your version of Llama for _ Amazon India, right? For example, Llama with Amazon India's knowledge. And that's a step called fine tuning, which we are not covering in this presentation, but that it exists and it has its own complexity and challenges. So here we are talking about ML ops and LLM ops. LLM ops and RAG is part. RAG and RAG as are part of LLM ops, right? RAG system, I create a system with the data I have. Let's say I have a chatbot to understand what procedures to follow, right? For an income tax department, if I have gains from this stock and I've held it for 500 days, what is the percentage of it, right? Those are close knowledge which public LLM need not know, but my income tax bot can know. And if I train that, and there is a new rule which comes up in April, modifications and changes are there. So I feed it back into it, retrain it, test it, and then move it to prod. So those kind of applications are called LLM ops, which again goes through the same cycle. But only that the LLM is always constant, usually constant. Only in fine tuning, we modify the LLM, but in LLM ops, the LLM is always constant, can be plugged and played, right? This LLM can be Ollama, it can be OpenAI, it can be Perplexity. I can use any model with a standard structure, and I can validate results also. So RAG gives that flexibility of using multiple LLMs for my same structure. The only thing, the embeddings has to be modified for that LLM. Embeddings are numbers or tokens, which are cut down and sliced down for that model. Yeah. So when I make embeddings for Olama, I will have to make new embeddings for the same text for OpenAI. Yeah, pretty much. Yeah, I took a lot from these sessions. Yeah, this is, the whole session is really built on Jane's article on how to evaluate models, and I learned a lot about LLM engineering from Udemy from this guy, yeah, Donald. So wanted to thank them. Yeah, so I'm pretty much done. It's 1 hour, and if you have any questions or anything I need to touch upon, can let me know, or I'm pretty much done with what I had to. Revisit just to see if I had anything I wanted to. TKI. Okay, I'm good. Yeah. If you have any questions or anything to touch upon, let me know.
Participants, you can ask your doubts or you can post the questions in the chat box.
No doubts, madam.
Okay, thank you. On behalf of the organizing team of AACTE Atal Faculty Development Program, I take this opportunity to extend our heartfelt gratitude to today's distinguished speaker for delivering an insightful session on LLM model basics, evaluation, arena, GPT, LOMA, industry applications, models in practice, and evaluation metrics. Your clear explanations, especially on the working of LLMs, along with the real-world perspectives, have helped us gain a deeper understanding of how LLM models are designed, evaluated, and applied in industry. The session not only introduced us to the foundations of LLMs, but also gave us the glimpse into a practical workflows and challenges in deploying these models effectively. I would also like to thank all the participants for their active involvement and thoughtful attention throughout the session. With this, we conclude session 11. We now look forward to continue our learning journey in the upcoming sessions of this FDP. Thank you, sir.
Thank you, ma'am. Thank you for the opportunity.
Dear participants, the feedback form for session 11 will be shared now, and session 12 will begin at 3:30 p.m. Stay connected. Thank you.